Alright folks, welcome back. Here we've got two questions that's been asked. The first one, once again, is pick the one that has the smallest atomic radii. So let's go ahead and just do this and knock it out of the way, and then answer the next one about the smallest ionization energy. Now the trend that you need to be aware of is which one to use. Remember, there's only two basic trends. In this one, radii, atomic radii, if you remember from the first trend video, atomic radius and radii in size, the trend increases going down and left to right. Wow, that is like the most crooked arrow. Well, that's not much better, but anyway, there's that. That's the trend for atomic radii, and the trend for the smallest ionization energy it increases going this way and increases going this way. I draw all mine for increasing. So let's go ahead and figure out what we're going to do here. So let's look at the periodic table. Our periodic table that we need to look at. I think I've got one open. No, I don't have one open. So that's going to be the next problem that we do. Let's see here. Here's my periodic table. Well, let me decrease this to about 90%. Alright, let's highlight the ones that they're making us do in this problem. Okay, and the first problem that we're working on, we're doing atomic radii. So let's try to get this knocked out of the way. So atomic radii is CSP. So CSP. Let's highlight those. C, S, and P. What's the other one? CSP, CL, and GE. CL and GE. Alright. Now if you remember, this is the one we're doing right now. We're doing radii. Okay? So we need to draw this trend so we can see it on our periodic table. Now the trend for increasing is going down, is increasing, and running across this way is increasing. So the largest one will be found closest to this lower left. The smallest will be found to the top right. Now, which one is closest to the top right? Well, at first glance, the one that's more to the right is CL. Okay? Just because it's so close to being to our top right. But if you remember, you have to go down to increase. So really, even though the CL is so much to the right, actually carbon is the one that is the smallest here. Okay? The largest one would be the GE. Carbon is simply the smallest because it's the one up higher. Okay? So if you want to think about it like this, between all of these, CL is smaller than S and smaller than P, and it is smaller than GE, but it's not smaller than C because it's further down. So CL itself is the smallest. So our smallest radii would be carbon on this one. Okay. Now on the smallest ionization energy, we need to look at that trend now. Hopefully I can get most of this out of our way. Alright, yeah. I got two left. Darn. Okay. So let me open up the periodic table again, because I need a blank one for us to use here. Alright, on this one, let's look at the other problem that we need to finish. We got CSP, CL, and GE. Same ones again. We got CSP to look at. We got, let's see, CSP, CL, and GE. Now, remember the trend for the ionization energy. It increases. Whoop, let me make that red. It increases going up, and it increases going across. So, meaning the largest would be up here, and the smallest would be down here. So, looking at that, the one smallest would be GE. So GE would be our smallest ionization energy because it's the one furthest to the left, lower left. Lower left is the smallest, and the top right is the largest. So anyway, there's that, and we know that GE is smaller than carbon because it's lower. So So anyway, there's that. So, all right, guys. I hope that this was helpful. Like I said, it's not rocket science. It's chemistry. So just follow the simple patterns and the trends, and you'll be fine. All right, guys.